Just like with any other technology, the value of Daml apps is amplified once the apps start being composed. When we talk about composing Daml apps, what we mean is utilizing on-ledger workflows from one app in on-ledger workflows of another app. In this lesson, we are going to introduce the global synchronizer as the default choice of synchronizer for composed Daml apps. We're also going to explain the alternatives to composing Daml apps on the global synchronizer and considerations for choosing the right synchronizer for your app. Finally, we're going to introduce Canton Network. One of the use cases for Daml apps is tokenization of real-world assets, which involves representing financial and other assets such as stocks, bonds, fund shares, or cash as smart contracts or tokens on a distributed ledger. As an example of Daml app composition, let's consider a fund tokenization app, which provides registry service for tokenized shares of a fund and allows transfer of fund share tokens from one app user to another. Let's also consider a cash registry app that provides safekeeping and transfer services for tokenized cash. Finally, let's consider a trading app that implements delivery versus payment or DVP workflow. This workflow provides atomic settlement for trades in fund shares, where the buyer purchases fund shares from the seller in exchange for cash. The trading app is composed with the fund tokenization and the tokenized cash registry apps. It uses the capabilities of fund tokenization and the tokenized cash registry apps to represent fund shares and cash as tokens and to transfer the ownership of these tokens from one app user to another. All three apps are sovereign. Each app is operated by its own app provider. The implementation of a DVP workflow in Daml by composing two registry apps was discussed in lesson titled Canton Multi-Domain Applications of the Daml Applications Design and Architecture course in the Daml Philosophy Certification Path. To refresh the implementation details, you may want to review that lesson. A DVP transaction, where the ownership of fund share tokens and cash tokens is atomically swapped between the buyer and the seller, involves 5 parties: the buyer and the cash app provider as co-signatories of the cash holding contract, the seller and the fund registry app provider as co-signatories of the fund shares holding contract, the trading app provider as the signatory of the DVP contract. To process the DVP transaction, we need a synchronizer that the participant nodes of all 5 parties are connected to. The global synchronizer serves this exact purpose. It provides the default infrastructure for composing Daml apps. It is publicly available for use by any Daml application. It is accessible by any app provider or app user. It allows execution of transactions that span multiple apps. The global synchronizer is a decentralized synchronizer operated by supervalidators, organizations that independently operate the validator and the synchronizer nodes, providing the global synchronizer infrastructure. The Global Synchronizer Foundation, under the auspices of the Linux Foundation, facilitates governance of the global synchronizer through transparency and member engagement in the decisions made by supervalidators. The global synchronizer is highly trustworthy due to its high availability and decentralization with a Byzantine fault-tolerant consensus mechanism. While the global synchronizer is particularly convenient for composed Daml apps, it can also be used as primary synchronizer for any Daml app. The transactions synchronized on the global synchronizer consume traffic credits, which can be purchased using Canton Coin, a utility token used for payments, transfers, and incentives. Traffic credits on the global synchronizer can be purchased by anybody, for anybody. When choosing a synchronizer for a Daml app, the app provider has 3 options. The global synchronizer, a private synchronizer operated by the app provider, a private synchronizer operated by a third party such as another app provider. These options are not mutually exclusive. Daml apps can be designed to synchronize some transactions on one synchronizer and others on another. For example, transactions that facilitate workflow composition with other apps could be synchronized on the global synchronizer, and other transactions, for example, the ones that are not dependent on other apps, could be synchronized on a private synchronizer. The choice of a synchronizer also doesn't have to be permanent. It's always possible to start with one synchronizer and then migrate to another. The considerations for choosing the synchronizer are summarized in the table. In all Daml apps, the app provider and users must trust the operator of the synchronizer for the availability of their ledger to process transactions, which is why in the previous lessons that focused on a single Daml app, the default assumption was that the app provider operates the synchronizer. This gives the app provider full control over this piece of the critical infrastructure required to run the app. In the case of the global synchronizer, the app provider does not have control over this infrastructure. However, the global synchronizer is highly trustworthy thanks to its decentralized nature and its tokenomics that incentivize the supervalidators to provide a reliable service. In the case of an app using a private synchronizer operated by a third party, the app provider delegates control over critical infrastructure to the third party. This is likely to be a viable option only when there's a close relationship between the app provider and the synchronizer operator that ensures the alignment of incentives. For example, when the app provider is a subsidiary of the synchronizer operator, or when the synchronizer operator is a consortium and the app providers are the members of the consortium. The next consideration is app composability. It's easier to compose apps on the global synchronizer because it's global, trustworthy, and public. When multiple apps compose workflows on the global synchronizer, the stakeholder Canton participant nodes have only one synchronizer to connect to, as opposed to having to connect to multiple private synchronizers. With private synchronizers, app composability is limited by each synchronizer operator, who needs to allow stakeholder participant nodes to connect to the synchronizer. On the global synchronizer, apps can be composed freely without restrictions. A private synchronizer is recommended for apps that require high throughput or low latency. Latency of synchronizing a transaction is generally higher on the global synchronizer due to its decentralized nature and Byzantine fault-tolerant transaction synchronization mechanism. The last consideration is cost. The global synchronizer eliminates the cost of operating a private synchronizer. However, for transactions synchronized on the global synchronizer, there's a per-transaction fee. Depending on the volume of transactions, it may be more cost-effective to use the global synchronizer for all or part of the workflows of your app. Or it may be more cost-effective to operate your own synchronizer. For apps with high transaction volume, a private synchronizer is likely to be more cost-effective. So far in this course, we focused on the topology of a single Daml app, which runs on Canton infrastructure with a single synchronizer typically operated by the app provider organization. The collection of all Canton infrastructure deployments is referred to as the Canton Network. The individual Canton infrastructure deployment, on which a Daml app runs, is a subnet of the overall Canton network. It consists of the set of participant nodes and the synchronizer used by these participant nodes for committing transactions that advance the app's workflows. The element that distinguishes one Canton subnet from another is the synchronizer, which is why we sometimes use the terms Canton subnet and synchronizer interchangeably. However, it is the participant nodes that make up the Canton network. Participant nodes connecting to multiple synchronizers provide the connection between Canton subnets and enable composition of Daml apps. Synchronizers are independent of each other and never talk directly to one another. Daml app providers and app users operate their Canton participant nodes, where they deploy Daml apps. Multiple apps can be deployed on the same node. The nodes store private app data for the Daml parties hosted on the node and provide a way of communicating with synchronization infrastructure, which ensures that this private app data is in real-time sync with the app data on other participant nodes. The participant nodes connect to private synchronizers and/or the global synchronizer. Since private synchronizers are typically operated by app providers, we often synonymize synchronizers and Daml apps, although such synonymization is not fully accurate, as a single synchronizer can be used by multiple apps and a single app can use multiple synchronizers. For example, consider a financing app developed by a bank, where the bank is the app provider that operates a private synchronizer. The app has the network of app users, issuers, investors, and service providers. We can say that by operating this private synchronizer, the bank is running the financing app. The global synchronizer facilitates composability of Daml apps by providing default infrastructure to synchronize transactions that span multiple Daml applications. With Daml, Canton, and the global synchronizer, atomic transactions can be executed across multiple apps without making trade-offs around trust, relying on an intermediary, or sacrificing privacy. The global synchronizer comes with a range of network utilities that participants can run on their nodes and which facilitate composability of Daml apps on the Canton Network. The Canton Network was launched by the industry to create a global open network like the Internet, adding guarantees of consistency and synchronization to unlock the potential of synchronized finance. It provides native interoperability for Daml apps and allows to connect siloed infrastructure and create sophisticated composed workflows across organizational boundaries while preserving privacy and control.